Good morning, friends. This is the EasyPower Refresher Tuesday edition. I'm Jim Chastain. I'm with the support team here at EasyPower, and each week we use this 30-minute time slot to offer some insights and snippets of technique and suggestions in using EasyPower tools. This morning we're going to focus on modeling busways in EasyPower. Certainly appreciate your attendance. We do record these sessions and they're available afterwards, usually by the end of the week, on the website. And before I launch into this, we do take suggestions on future topics, and certainly if you'd like to see a session on a subject that you think has been under-attended, you're more than welcome to enter that in the suggestion box or send us an email. What we're going to talk about today is busways, sometimes referred as bus ducts, popular in a lot of applications since the mid to late 50s, primarily because of their cost advantages versus a conventional cable-connected system. These advantages fall primarily into the area of manpower because you can make changes relatively simply when the bus ducts or the busways are mounted in the overhead and you need to move a piece of equipment or change the production line. It's relatively easy to disconnect a system or a machine and move it somewhere else in the plant without having to move a lot of cables. The units usually are composed of fixed, or the busways themselves, of fixed elements, and it's a matter of, during construction, linking these together and then making sure that they're safely installed and meet your needs. So before I go into that, let me kind of offer this is the first of my polls. Just want to gather some feedback on how people utilize busways, how often they run into projects. And again, the focus here is going to be on modeling them. One of the things you'll find as we get into the examples is it's a different paradigm. It's a different way of looking at something that you're relatively familiar with. And once you see the technique, if you will, if you don't use it often, it may be something that you forget or don't necessarily attend. And so I invite you to kind of come back and look at this refresher, because again, it's relatively simple to deal with once you embrace the technique. So very often when these are used in commercial and industrial advantage applications, it is because of cost savings, and they don't have to be redone as far as a distribution system. And again, they're NEMA rated and pretty straightforward. EasyPower handles these differently than we do cable systems, in part because there's a finite number of manufacturers and the systems don't change once they've been installed. But what it does require is, as we approach the modeling requirement, that we consider a different paradigm when we're looking at the system. Turns out the cables are virtually all of a different length and they're variable impedance to each load. The busways, once it's installed, have a fixed length, and it's the loads that end up moving rather than the cables. And so the problem is still the same, and that is whether or not to deal with the changes at each time we do a impedance change or a distance change when we move a piece of equipment around. So the technique, again, it can be handled exactly the same way as a cable, but that requires, if we do that, changing the model every time in terms of the length of the busway. And you'll see as we get into the model, the icon for busways is in the same general category as cables. The advantage is, if once we have installed the busway system, if we consider the overall length to be the total impedance for the system of the bus, and then we calculate or create an average increment that we want to utilize for the length. Once we do that, then we, if you will, lump or group the loads within each length to show them in our model. So there's going to be some amount of averaging, and as opposed to lumped loads, which we might have in a cable or a panel, what we're going to do is essentially lump the impedance of each length and then stipulate which loads come down based on the grouping we have or that we're showing for that section of the busway. So the first example I'm going to jump into is a 600-foot busway that's installed down the center of a plant, and it's using a standard Cutler hammer product. The equipment is installed at drops at very different intervals between 10 and 25 feet separation. So if we were to match the actual physical model, it would involve lots of buses, and each time there was a change, it would involve a significant amount of updating to the system. The advantage of tackling it with this paradigm difference is that if we model the average load separation, or we set a standard separation between load connection points of 100 feet, and then we group our loads at those connection points, it gives us a way to kind of make updates or change the model pretty much as simply as we do the physical installation. And then on a second example, we're going to show how the same switchgear that we use, or the similar switchgear that we use for installing cable systems with panels and MCCs, there's the same type of capability when we're looking at multiple busway installations. So let's kind of jump into the tools and get to it. Let me kind of launch this last poll and get a little bit of feedback before I get into these details. So typically, well, how long is the busway that you have to deal with when you're doing a system? So what I'm starting with is here's what the results are. Looks like people are having to deal with some fairly large systems. All right, so what I'm going to do here is start off with a system that I have kind of a typical utility installation. I'm using my basic utility cutout fuse. Let's go ahead and put in a fairly good sized transformer. And this is all generic stuff. And then I've basically connected some cable runs with about a 2200 amp capacity going from the utility to my first busway, or my first switchgear. And from there I want to run my busway. So in this case I have a 600-foot run, and I've decided that I could use for simplification purposes, I want to use 100-foot sections. And to do that, I'm going to average at the connection points the loads that are within 50 feet of that particular connection point. So as I mentioned, as I go over to my menu, I can see busways listed here very much like I would pick up a cable. And I'm going to take the busway from my breaker connection, and at that point I'm going to install a connection point or a bus. All right, so this will be my first drop. The first one I'm going to set up at 50 feet. So let's go ahead and hook this puppy up there. And then the next one is going to be 100 feet out. And so I'm just going to do a couple of these and you'll see what the net effect is. So again, I've made the decision that I want to have my drops basically consolidate the loads that are within 50 feet each side of this. So this drop will take care of everything between the breaker and this first 50-foot length. And then the next busway, I'm going to connect between this drop point and the next one out, and this will be 100 feet. And in reality, I probably want to point these down so I can see my connection points. All right, so now that I've got this kind of started, I want to come in here and characterize what my bus way looks like. So as I double click on it, it opens up my standard data dialog box. And here, we're going to pick out the manufacturer. In this case was Cutler Hammer. And we have a standard CP3P product line. And the first run is 50 feet. So I'm going to calculate that. Now you notice we don't have any other settings to deal with. Obviously, we're not going to be dealing with harmonics here, but very frequently there could be harmonic contributions or susceptibilities or radiation from some of these busways. And so that's a considerably more advanced discussion. But for now, we're going to save this. I'm going to take this same, all these values, copy into the second one. And now as I open this up, this is going to be my 100-foot length. Now, what I'm going to do, I can either take the bus with me or not. I'm going to control copy, and then let's set it down here. And then just stretch these out at each connection point. Put another one over here. So you get the idea now. I've got 1, 2, 3, 4 drops, and 50, 150, 250, 350. I've got a little over half of my plant kind of set up this way. All right, so now in terms of setting up the equipment that's coming off of the drops, I want to take, and I can either lump these or detail them as much as I want, but let's say within this first 50-foot run, I have a 25 horsepower motor that comes down off of a 10-foot cable from the drop. Now the physical drop may actually be out here at 25 feet somewhere, but the fact that I'm averaging it, so what I'm using is the actual 15-foot cable that's going to come down from the drop at the 25-foot point. And let's say each of these has a fuse. And so as I go in here and detail my motor, and I think I said this is 25 horsepower, we can go ahead and set it up. I didn't notice full current, 35 amps. All right, and this is a 10-foot length of cable that comes down. And then set my fuse up for, let's just use generic fuses. And let's say it's 40 amps. All right, then for each of my other loads that are going to be within 50 feet, so anything between the breaker and this first 50 foot of run, and then everything out to the first 100 feet, which would be halfway through this next run, I want to put those pieces of equipment either lumped or individually here. So let's say I have a panel that comes down from here. So I might put on a panel schedule, and it too might have a fuse interface. And it might end up with cable, something like that. All right, so you get the idea. Point being, and place where we're going to run into problems or the significance of what's going on with the busway, is the fact that we have a limited amount of protective devices in line, and so consequently the busway itself gets daisy-chained, and all this impedance starts to add up. So as we get down to the end of that 600 feet, we will end up with some fairly or potentially hairy arc flash instant energies, even that could be carried down to the drop point if we haven't got the proper protection. So let's see, I guess I need my motor. Let's say this is a 10 horsepower. I got to put it in the right place. Okay, let's see where this is taking us. All right, I've gone from my database editor now to short circuit focus. We're going to fault the buses. You can see we're getting 34,000 bolted fault current amps to the first bus. Went up 27,000 to the second, if you will, average drop list. And then it gradually reduces. The significance of that is when we go in and calculate instant energy, it's going to gradually build up because a fault at this drop point, although even if it's averaged, is going to be protected by the settings on this particular breaker if we have no other inline protective devices. So, interestingly enough, it doesn't hurt our it doesn't really affect our protective devices or our drops or the loads here, but it is something that we need to be concerned about if we have anything near or anything that could cause a fault up in the busway itself. So let me jump to another example here where I've kind of got more detail on this. All right, so this is essentially 1,000 amp capacity. Looks like I've got about 800, 1,000 foot, 200 foot links. If I go into short circuit, fault the buses, you can see I have exactly the same type of predicament here, that my incident energy builds up as I get farther down the busway, but as long as I'm mindful of what I'm doing to protect the loads or the drop points, I still have a relatively safe situation. Okay, then the last thing we wanted to point out is all this could be done with, well, before we go there, let's kind of look at what we see from our arc flash hazard report. One of the things that will show up, depending upon what kind of breaker we have upstream, is, in fact, in this case, it looks like the fuse is a limiting factor for the buses as I get farther down the loop. Yeah, so BL1 is the trip device that's protecting everything upstream. So everything down to bus 11, BL1 is the only thing that's in line. And the point I wanted to make is, in some of these cases, we see magenta type, which means the incident energy is greater at the 85% current level, arc current level, than it is at 100%. All right, then the last example I wanted to show is the one that has the where we've used the wizard to create a multi-busway distribution system, and quite literally, let's say we had the need to put another distribution system like this. I can use my bus switchgear wizard, and instead of using cables, we could use busways, include a main breaker, and now we're set up, in this case, to go with exactly the same type of distribution system. And then when I think in terms of averaging, now this will be the first leg of a multi-busway distribution center. And so I take my busways out just like I did before to the next drop point. So the task becomes one of understanding the trade-offs involved, understanding how what the protection scheme we're trying to achieve is. As you can see, it's relatively easy to control the exposure that anyone is going to have below the drop point. The sensitive area is going to be up in the busway itself, and as long as we're maintaining that as a closed system, or anytime we do work on it, we make sure we have a de-energized system to work on. It should be a relatively straightforward and safe procedure to be able to deal with and manage with my maintenance staff. Now, as the one thing I would suggest is, as simple as this appears, it is something of a paradigm shift, or at least it was for me, and so it's worthwhile coming back and retrying this. And sometimes your first order of approximation, let's say I want to start with a 10-foot bus extension, or if every one of my sections is going to be 15 feet or 25 feet, I end up with a lot of buses. And as soon as I make a change, I have to change that. Again, this is a daisy chain situation, and certainly that can be done. But let's say if I move this particular load or this particular group of loads from, in this case, I've got them lumped at 200 feet. So let's say I move one at 75 feet and the other one has to go down to 130 feet. Now I'm breaking this up. It doesn't change the way this is all handled. And again, the differences are going to be up here in the busway itself. The drops and the ability to control that energy is still primarily between the connection point or the bus plug and things downstream. I do want to make one more kind of announcement. Certainly, if you have questions similar to this type of subject or anything else, you're more than welcome to contact tech support at easypower.com. I wanted everyone to know that we have posted on the website several of the training sessions that will be held later this year. I believe we're going to have at least 6 different regional trainings, and the first 3 or 4 are up on the website. Certainly, if you are you working on your first systems, or you have some aspect of your model or your project that you need some more advanced support, or you'd like to see us do a study for you, be more than happy to give you a quote on that. Send us information or a one-line that you've created, and we can quote you time and materials to kind of get you up to speed to show you how we would handle that type of study. Appreciate everybody attending.